All right, this is the Geometry Unit 5, Lesson 4 video over the triangle midsegment theorem. So I'm going to kind of try to crystallize some of the info here into just some brief information about what a triangle midsegment is. Sorry about that. Triangle midsegment. So triangle midsegment is if I have a triangle and I find the midpoints of these two sides, connect that. This is what we call the triangle midsegment. So the triangle midsegment is a line segment connecting two midpoints of a triangle. So this would just be one of three. There could be another one, give you an idea, another one that could be here. There could be another one that could be here. But in general, we're going to focus on just this one for now as we talk about the definition. So again, this is the midpoint of this triangle. Let's go ahead and call this triangle A, B, C. And when we have a midsegment, there's two things that we know about it. Number one, midsegments are parallel to the third side. So we have our two sides that we use to make the midsegment, AB and BC. And so then in our case, we'd say MN is parallel to AC. And then also, it's half the length of the third side. So in other words, MN is equal to 1/2 the length of AC. Another way of thinking about that would be to say that AC is equal to 2 times MN. Those would both be saying the same thing, but in a different direction. So that's really what you need to know about midsegments. Let's jump over to the lesson. So there's a lot of other information in here, but generally speaking, that's what's described here in the midsegment theorem. I'm going to go over this proof first, and then we'll talk about the other information here. So we have YZ, ZX, and XY. They are midsegments. So it's these line segments here. Oops, let's go and erase that. That's the segments that are here, here, and here. They are all midsegments. And then it says here that YZ is equal to 1/2 of AC. So AC is this. So yeah, that would be half. That's part of the midsegment theorem. Let's go down and look and see. We look for the midsegment theorem. Triangle midsegment theorem is going to be answer choice G. So that's going to be the triangle midsegment theorem right there. X is the midpoint of AC. Okay, that's the definition of the midpoint. Definition of midpoint. Definition of midsegments right here. So it's going to be answer choice B, because since these are midsegments, we know that X has to be the midpoint. Then we say that AX is congruent to XC. That's the definition of a midpoint. And then we convert that into a statement about the length of those segments. So instead of line segment AX is congruent to line segment XC, we're just going to say AX is equal to XC. So that's going to be this one right here, answer choice I. So that's going to be answer choice I right there. Then there's some kind of working things out here. AC equals AX plus XC. AC equals, we replaced XC with AX. AC became 2AX. And then we did divide by 2 on both sides to get AX equals 1/2 of AC. That is going to make us substitute from this statement right here. We're going to substitute right there. So let me just actually make that more clear. We're taking this statement and we're substituting right here. So that's the transitive property of equality. One second. Substitution property of equality. That's answer choice C here. And then what's our next one? Well, since those are equal lengths, we're going to convert that back into a statement about segments. And we know that because of what it says right here, definition of congruent segments. So we need to convert what's in line 10 into the same statement about segments in line 11. So it's going to be that choice. And then we are using the mid-segment theorem again to say that YZ is parallel to AC. That's what they've said there is the triangle mid-segment theorem. And then since those are both parallel, that forms a transversal line. And that transversal line tells us that those are alternate interior angles. So that's going to be answer choice F. And then that's anytime, we talked about this in a previous proof, anytime we have a segment being congruent to itself, that's what we call reflexive. And so that's going to be answer choice K for that one. And then they've used that to prove the triangles are congruent using side, angle, side. All right, so looking from there, we've got some vocabulary that's going to come from the lesson above. Let me just scroll down to make sure. Yeah, so the rest of this is going to come from this one diagram, and I'm kind of going to get you started on a lot of this. So they've given us some information. They've told us that DR is 4.5, TF is 4.5. They've also told us for sure these are mid-segments. So just to kind of get you started here, that also tells us a few key things. First of all, these are all midpoints. If the green lines are mid-segments, then R, S, and T are all midpoints. So what you're going to be doing is answering questions based on that information. So pretty straightforward, like in this first one. TF is 4.5. What's EF? So that's asking about this entire length here. Well, if that's the midpoint, that's 1/2 of that length. So you should easily be able to find the length there. More of the same down here. You're going to calculate all the various lengths. So use these values, 4.5 here and here, to calculate all these values. I'll just go ahead and say this first one, that's going to be 9 centimeters. So EF is going to be 9 centimeters because this is also 4.5. Similar idea for the rest of that. So that's the same thing you're going to do for number 5. Number 6. Number 7, same idea. Number 8. Now, in this one, you need to calculate the length of SF. SF is this length right here. It's part of a triangle that's made up of these lengths. And that is a right triangle. So they tell you specifically you need to use the Pythagorean theorem to find oh my gosh, sorry guys. I am struggling to write neatly today. All right. You need to use the Pythagorean theorem on the triangle you see here in green and blue to solve for the blue. And of course, that blue length is the C value. So this is A, B, and C. Same thing in number 9. You are going to know SF based on the previous problem. So once you find that, remember this is a midpoint, so DS would be the same. And so then you should easily be able to find the length of DF. Calculate the length of RT. Same idea as the previous 2 problems. I think if you kind of use common sense, you'll be able to figure out that one. Same thing. Oh, what is triangle RST called? RST is, oh, that's a definition from the lesson. Let's scroll up here real quick. So right here, there it is. It says here, triangle is, where is that? There we go. The triangle made out of it is called a mid-segment triangle. So RST is a RST is a mid-segment triangle. Right there. Then you just answer some questions. You can conclude about the relationships between DRS, RET, STF, and RST. I bet you can figure that one out based on what you discovered through the process of doing the previous problems. They only have one congruent. They're all congruent. They're different sizes. Two of them congruent, but not a third. They only have a right angle in common. What do they have in common? What's the most conclusive thing you can say? And then what is the area of RET? Okay, give you a hint. Remember the formula for triangle area is that the area of a triangle is equal to 1/2 base times height. So base and height in that triangle are going to be, here's your base, this is your height. You should be able to figure that one out easily. And then what's the relationship between the area of RET and the area of DEF? So again, you're going to want to calculate the area of the triangles and make a comparison between the two. Again, you already have, by the time you get to this step, you know all of these lengths. You're going to know all the lengths of every single part of this triangle, and you're just going to use that to find the area of the largest triangle here in blue, and then compare that to the measure of this triangle here and make a comparison. That is it for lesson 4.